boldly engaging the mindless propaganda of our time, apparently with reason. This is Rage of the Age.
This is Rage of the Age, and we have with us today the Professor of Biochemistry of Lehigh University. He's a senior fellow at the Discovery Institute Center for Science and Culture. He's the author of Darwin's Black Box, the Biochemical Challenge of Evolution, and he also has a new book coming out shortly called A Mousetrap for Darwin. I want to introduce to you today Michael Behe. Michael, welcome to the show.
Thanks very much. It's great to be with you. Looking forward to the conversation.
Well, me too, and this is actually quite an honor for me. I can't remember what video it was I watched of you one time, and you were discussing everything that you talk about with irreducible complexity. I never heard of it before. And you were talking, they were showing all the wiggly things on the screen or whatnot. But as I watched it, I was like, wow, this is so amazing. You know?
Most people, when they think about living things, think about squishy stuff. But science has discovered that, the molecular and cellular foundation of life is filled with machines, real machines made out of proteins and other biological molecules, not out of steel and plastic, but out of protein.
Well, and that was one of the things that caught my attention because, I think biology, because I've been taught to think this way, I'm thinking there's this fluid thing of life, just whatever things interacting with each other. Most of it you don't see anyway, so whatever. But machines, though, that's a different look at it.
Yeah,
right?
That's a whole different ball game. Yeah, squishy things can, kind of come together. As a matter of fact, that's what Darwin and his contemporaries thought back in the middle of the 1900s. A guy named Ernst Haeckel and Darwin's buddy Thomas. Now I forgot. But anyway, they found some slime from the sea bottom that a research vessel had brought back, and they thought that life was kind of oozing up from it. So they didn't know about cells very much back then, and so their imaginations went wild, and they just thought life could arise spontaneously.
Because if I remember right, at that time, we didn't have the microscopes to actually look into a cell beyond just like a blob, right?
Exactly. Yeah, there was no electricity back then. So you had to use candles or sunlight, and the resolving power was not good. So all people could see was a kind of funny looking blob. And so they christened it protoplasm. And seems like protoplasm could do anything, but since then we've discovered one or two things about the cell which complicate the picture.
Yes, and one of the complications is, as you've put it, the irreducible complexity. Now, for those listening to hear that, whatever that may be, can you ironically break that down for us to the lowest possible to understand what that means?
Yeah, it's a fancy phrase, but it's a really simple idea. It's that in my first book, Darwin's Black Box, I used the example of a mousetrap from our everyday world to illustrate it. You think about a mousetrap, it's got this wooden platform and a spring and a bar that snaps over and another bar that holds it in position until the mouse comes along. And it needs all those parts to work. If you take away the spring, you take away the platform, it doesn't work at all. It's not like it works half as well as it used to. So it's complex in the sense that it has a number of different parts, and you can't take it away, take any of the parts away, so it's irreducible. And so it turns out that most machines are like that they need at least a number of parts in order to work. And it turns out that science has discovered in the cell there are molecular machines made out of molecules, real machines like like an outboard motor that boats use to propel themselves through the water. There's something called a flagellum that bacteria use to propel themselves through the water. And there are little trucks and buses, and there are little highways made out of molecules. And one of the key things is that almost all of them need multiple parts to work. And Darwin's theory said that random variation and natural selection had to improve things slowly in tiny steps over long periods of time. But if you need multiple components to get started, then you're dead in the water. There's nothing for natural selection to select. If how would you build a mousetrap, improving things a little bit at a time? It's real
Right.
difficult, real difficult
Yeah.
to figure out, and it's even worse for the molecular machinery of the cell.
Yeah, when I think of the mousetrap analogy you used, another one that comes to my mind is the discussion they used to have a few centuries ago about the watchmaker argument. But when I've had that discussion with other people, and usually the response is, well, yeah, if you're dealing with actual machines and parts and stuff like that, yeah, but this is biology and this is evolution, and you don't have to have these parts or anything. So you're saying from your professional observations and actually seeing it, there actually are machines in at the lowest levels of biology.
Yeah, and it's not just me. That this is a common term, molecular
Right.
machines, that's used in
Uh,
biochemistry. Everybody says machines. There
mhm.
are papers that ask the question, why do we call them machines? We call them machines because they're organized. They use force for a particular purpose, just like our machinery. So unless you're kind of a vitalist and you say that there is this magic aura that's going out, then they use the same principles as machinery in our everyday world. And again, people, yeah, I've run across a number of folks who say, well, biology is special too.
Right. Yeah.
But then they'll turn around and say, no, biology isn't special because life is just like non living matter and arose from non living matter. So they kind
Yeah.
of try to have their cake and eat it too. But I first proposed or used the example of the mousetrap back in 1996 with the first book, Darwin's Black Box. And in my own completely unbiased opinion, nobody has been able to propose a plausible way that even a simple mousetrap could be put together by Darwin's criterion, what he called numerous successive slight modifications. And
Hmm.
what's more, it has to be random. There has to be no
Right.
mind guiding it. And so if they can't even propose something plausible for a mousetrap, molecular machinery is well beyond them.
Well, and I think that's something that really caught my attention when I saw the thing that you had in the video going and whatnot. And that was a few years ago. It really, really caught my attention because I was rejecting evolution just based upon what they proposed as the why just didn't add up. Like that doesn't solve anything. It doesn't point to anything. But when I saw you with the little machines doing the thing and you were explaining how irreducible it is that if you you could test it. This is something
Hmm.
because they
Yeah,
can't really
yeah,
test their stuff. You
absolutely.
can't
Yeah,
falsify it. But you were like, but you can test it with what you're saying by take a protein out of a cell and see if it functions by itself and live.
sure. Yeah, yeah, yeah. There's no doubt that many things in the cell are irreducibly complex in the sense that you can take a piece away, just like the mousetrap, and it no longer works. The criticisms or the responses I've gotten is, well, maybe in the distant past, something could work with fewer parts, and then maybe it went over here and picked up another part, and over here and picked up another one,
Right.
and voila, at the end it turns into a molecular machine. And you can't argue about vague stories that are untestable. But you say
Mhm.
that when we look, nothing like that goes on. Uh, and as a matter of fact, in my newest book, Darwin Devolves, it shows that scientists have found that in laboratory and evolution and other places too, that Darwin's mechanism most frequently breaks genes rather than making complex new structures. So,
Yeah. I guess the term I've heard used is symbiotic relationships, where at some point they got together, can't do without each other now. But to me, that's a poor demonstration because that's a social description of people relating and animals relating to people, which can be broken and they can go back to their
mhm.
own individuality again. Whereas in your scenario, there is no separating.
Yeah, that's right. Well, think of the mousetrap again. You know
Mhm.
what symbiotic relationship gave rise to a mousetrap? You know, what was the spring doing? What was the
Mhm.
spring doing before it became the spring of the mousetrap?
Right.
And even if you say, well, maybe there was a spring in a grandfather clock that, maybe it came across a crowbar, which
Right.
we fancy could be used
Which
as
in a
a
billion years might happen, right?
yeah, sure. Yeah, hey, all you have to do is, close your eyes and imagine it. But, when you get serious, which
Yeah.
science is supposed to do,
Right.
these things fall apart very, very quickly. And so the bottom line is that nobody in the National Academy of Sciences, no Nobel Prize winner has any explanation for how these things might have arisen by a Darwinian type mechanism.
Right. Now, speaking of falling apart, um, I guess the idea is prevailing now that there's a beneficial mutation happened some ages ago and somehow survived, creating something better. And of course, if you have a billion years, it might accidentally create what we have now
Hmm.
by random chance.
Right.
In my head, and I'm not trained in the sciences, so I can't speak this with too much authority, but my understanding is if there's a mutation, it's usually not beneficial at all. Do we have any examples of a beneficial mutation?
Well, yeah, we do, but they're not the kind that you would need to build complex structures. Yeah. It's been known for a long time, since the 1940s at least, that say 99.9% of mutations are
Mhm.
harmful to
Okay.
organisms. And
Right.
just as your friendly family doctor, whether a mutation in his patients, is beneficial or not.
Right.
Uh, but it's interesting that in recent years, scientific techniques have advanced so that we can trace mutations a lot easier now, and people have tracked down what are in fact beneficial mutations.
Hmm.
And the new surprise is that many, in fact, the majority of helpful beneficial mutations are ones that break genes that were already there. That if the environment changes or some such thing, oftentimes you can adapt to an environment by breaking a gene. And I give a number of
Okay.
examples in the book. And one I start out with is a polar bear. It
Hmm.
turns out that the entire DNA of the polar bear and the brown bear, grizzly bear, from which it's thought to descend, have been elucidated, have been sequenced. And scientists did it because they wanted to see, well, what mutations did you have to get
Right.
to produce a polar bear from a brown bear? And it
Hmm.
turns out that the top dozen or so helpful mutations are ones that broke genes or degraded them so that they work
Mm.
less well. And the easy one is, well, there's a gene involved in producing the brown pigmentation for a brown bear's fur. And polar bears benefit from not having any pigmentation. And so one of the genes involved in that had a mutation which broke it. And
Wow.
there's a number of other ones like that too. Darwin's finches, people might
Hmm.
know those as an example of evolution. And some of them have sharp beaks, and some of them have shorter and thicker beaks.
Right.
And it's only been, 5 years ago that the mutation that produces the thicker beaks was tracked down, and turns out to be a degradative mutation in a gene that was already there. And I should tell the listeners, just in case, when you think a mutation comes along and does this, or a mutation comes along and does that, that's almost never the case, because a single gene, and we and other vertebrates have tens of thousands of genes. A single gene might have 1,000 different parts called
Right.
nucleotides.
Mm.
And generally, a mutation is a change in one of that 1,000. And in order to get some significant new um, positive feature, you would be expected to need many, many mutations. And we don't see that when we look.
So this is fascinating. So the changes that are beneficial don't really create anything new. There's no new data, there's no new DNA. You take what exists and you basically break it down.
Exactly. A good example are human genes that have evolved for resistance to malaria in
Mhm,
the
mhm,
equatorial regions of the world. And the most famous is the sickle hemoglobin gene.
mhm,
And that is one change in the hemoglobin gene that was already there, which for some reason causes the hemoglobin to kind of solidify, and your red blood cells go from things like bags of water balloons to something like bags of cement. They become very rigid, and the
yeah,
malaria parasite lives in and eats red blood cells, and that
mm,
messes up its home in us and confers resistance. But it's actually a degradation of the hemoglobin,
right.
not the production of something brand new. It's not even in the immune system, which generally takes care of microscopic invaders. And there's a handful of other mutations that popped up for malaria,
Mm,
and they cause any number of diseases. There's something like called thalassemia, where some genes for hemoglobin are broken, and something called glucose 6 phosphate dehydrogenase deficiency, where an enzyme in the red blood cell, which is generally used and helpful, is broken, and a couple other ones too. So when you think about it, it's not surprising, because it's a whole lot easier to break a gene than it is
mhm,
to make one. Just like, and it's easier to break a machine like your
right,
car or your computer. You take a hammer and go bam here or bam there,
right.
than it is to make one. So if there is a benefit breaking something in some circumstance, then go for it. Natural selection, random mutation, they don't have any minds. So they'll just use the first thing that comes along. And
Mhm,
I give another example. People say, how can breaking something help? Well, suppose that, you had a real nice car, but now for some reason your life depended on your car getting a bit better gas mileage. What could you do quickly to get better gas mileage? Well, you could take off the hood of the car and throw it away. You could take off the doors, lose excess weight.
right.
And of course, doors and hoods and stuff are useful in many circumstances. But if your life depends right now on getting better gas mileage, that's the way to go. And in many instances, all sorts of situations, it's good to toss something overboard rather than keep it and suffer some problems.
So your book, Darwin Devolves, that's pretty much what you're tackling. It's showing more de-evolution than improvement through evolution.
Exactly. The point of Darwin Devolves is that most evolution that people have talked about, most helpful evolution, most adaptation of species to changing environments and stuff. Now it turns out that that's due mostly to breaking or degrading genes, and people forget that it's only been in the past 10 or 20 years that we've really been able to test Darwin's theory at the molecular level,
Right.
where that's where stuff happens in life. That's where the rubber meets the road. Mutations, it turns out, are molecular changes. They're mutations in DNA, and DNA carries the information for making the proteins that make up the molecular machines of life. So if you want to know what Darwin's mechanism of random mutation and selection do, you got to look at the DNA changes. And we just couldn't do that until 20 years ago at best. People would see that changes came along. Maybe a brown bunny rabbit gave rise to an albino bunny rabbit, did better in snow, but they didn't know why or what was going on at the molecular level of life. But now we do, and it turns out that it's not by building stuff, but by breaking stuff that changes happen.
You're listening to Rage of the Age. Rage of the Age. Politics, religion, economics, and history with a conservative bend.
Yeah, that's always baffled me with the theory, even before this irreducible complexity and the molecular level observations. I mean, for thousands of years, human beings understood animal husbandry. You breed this one with this one, you'll get this result. Things change through mainly through procreation, and that things can alter through time in certain regions. We knew this. It wasn't like Darwin just discovered it or something by himself, but it's when they took that idea and just ran amok with it to like where an entire new species can just form out of that process. But molecularly speaking, that doesn't seem possible, does it?
No. You do have to make some distinctions because evolution can do some things, little things, but sometimes they're medically important or they give rise to some noticeable feature in an animal. But again, it's due to tiny changes at the molecular level. So yeah, you see those beaks in the finches and you say, wow, yeah, that's really cool. It turns out that that's likely due to random changes and selection. Well, okay, but can anything build new organisms or do anything other than kind of working at the edges? And in my book, Darwin Devolves, I look at a number of organisms that have been held up as icons of evolution or really cool evolutionary families because they have lots and lots of species. The finches are one. There's a dozen or more species on this small chain of islands, the Galapagos Islands. There's some fish called cichlid fish that occur in large lakes in Africa, Lake Tanganyika, Lake Victoria, and so on. There are thousands of them, and it turns out that there's thousands of species. Species is the lowest level of biological classification, and they are classified into a number of genera, and genus is the second lowest. But there's no new families no new families or higher order classifications, orders, and so on. So it seems very, very likely that, yeah, when you have an organism, it can suffer mutations which will kind of bop it around different species and genuses, but you can't get a new family by random mutation and selection. And just for the listeners, a family level distinction is like cats versus dogs. You know, you can get different cats, you can get different dogs, wolves, foxes, stuff, but you're not going to get a cat from a dog or vice versa.
So you'll have all kinds of variations of like dogs. You know, you'll have the terriers and the hounds and the different breeds and whatnot. But that dog's not going to suddenly one day sprout wings and fly off.
No, probably not. And it's interesting, though. Also, in the past 10 years, scientists have become very interested in the breeds of dogs and their genetic differences, simply because they want to ask about evolution.
Right.
And they have tracked down many of the mutations, and they're pretty much all degradative changes. So if you want a dog with short legs, then you break the gene that decides the length of legs. And if you want curly hair, then you can break a gene involved in the synthesis of fur, and it turns out to give these strange curls. And if you want a dog with a short muzzle, like a bulldog, you break a gene involved in facial development.
Right. Yeah.
So they have been pointed to as displaying the great powers of evolution, and they do show us how evolution works.
Right.
But now we can track it down at the molecular level. It's a whole lot different from what they expected.
I guess to me, for the longest time, and I'm sure plenty others, evolution kind of has this mystifying thing too, because there are some observable effects of changes over time. But then what appears to happen is they take and go, look, see, these changes happen. Therefore, everything sprung from some change somewhere. Yeah. And it's like they take a huge logical leap from what we observe to, I don't know what they want to be true. I don't know what drives it, but
it's kind of like saying that, well, you know, our cars can take us a lot of places, so maybe cars can take us across the ocean, and cars can take us to the moon, and so on. Extrapolating from your results is always tricky, but it's common in science to find that a theory that worked for some things isn't working when you get the ability to test different more stringent conditions. The big example, of course, is Newton's theories of physics and his laws and stuff. And then Einstein came along and, you know, said that those laws break down at faster speeds and larger weights and so on. So Darwin's theory is great. It works for little things, and it's important medically for people. Antibiotic resistance, break a gene that a drug interacts with in the bacteria, and the bacteria no longer are sensitive to this drug. But it does not explain where life came from. It doesn't explain any of the coherent and elegant features of living things.
Right. Now, in Darwin Devolves, I believe you were talking about strains of yeast over like thousands of generations or something in labs in China. Well, what were some of the discoveries from that? Because I want to make sure I understand it before I elaborate on it.
Okay. Well, the best evolution experiment that we have was started by a guy named Richard Lenski, who's actually in the United States. He's a professor at Michigan State. And in around the year 1990, 30 years or so ago, he got the idea that he would take bacteria called E. coli, Escherichia coli, which are a common laboratory strain that people use to do experiments. And he would let them grow in a flask with enough food in solution, sugar, for them to reproduce. And since they're so small, they reproduce rather quickly, so they can go through six generations overnight.
Right.
And since they're so small, in a tiny flask, you're going to have 100 million of them.
Wow.
So the next morning, he would come in and take a little part of that flask and use it to seed a new flask with fresh nutrient broth in it, fresh food, and let it go another 6 generations overnight. And then the next morning, do it again, and the next morning. And he's been doing it continuously for 30 years.
Wow.
Turns out the bacteria have gone through about 70,000 generations at this point, and there have been trillions and trillions of organisms in his flasks. And so he just wanted to watch what they would do, how they would evolve. And he saw pretty quickly that some bacteria with different shapes would outgrow the starting strain, and then other improvements would come along. But back then, back in 1990, he couldn't identify what the mutations were, simply because the technology wasn't available then. But in the year 2000 and going forward, he was able to identify the exact molecular changes in genes. And it turns out that the top 30 mutations all broke genes. All of them did. One of them was in a gene that is needed to produce a flagellum. Remember, a flagellum is that outboard motor, very complex.
Right.
And the first thing it does is jettison this machine, because in his experiment, the flasks of bacteria are shaken by a machine so that they get distributed nicely, and so they don't have to swim anymore. So they can just not waste the energy on making this outboard motor and use it for reproducing faster. And all sorts of genes have been tossed out. So they do improve, but with each gene they break to adjust to the environment, they become more genetically brittle. They have less and less options then when circumstances change in the future. And one strain of bacteria that he was looking at, a specialized strain of this E. coli, was able to eat a laboratory chemical that it couldn't before, but it turns out that was due to a broken gene too. And now it has gone on to successively lose more and more genes, and its death rate, the number of cells that kick the bucket every generation, has gone from about 5% in the beginning to greater than 50% now.
Wow.
So it's really one sick puppy. So that is that's what evolution does. It adapts you, but it costs you, and it does not build anything.
Because that's the basic premise of the idea of the theory of evolution, to account for where everything comes from, is something simple builds into something more complex, and then it builds into something more complex, and so on, to account for the more intricate creatures, if you will.
Yeah.
But what we're seeing is that don't happen. If there's any of these changes, it breaks down something. It doesn't build upon something.
That's right. One of the examples, or at least thought examples, is a cheetah hunting a gazelle. Cheetahs are fast, gazelles are fast. So if the cheetah starts to get too fast, more gazelles get eaten, except the fastest ones, and they can't be caught. And they survive, and they have a new generation of gazelles that are real fast. And now the cheetahs are starting to go hungry, and only the faster cheetahs will survive. And so there's this race. But again, that's all in the imagination. That's at the level of, thought. Nobody was looking at the actual mutations, the actual molecular changes that had to occur. And so only recently have we developed this ability, and nobody's looked at cheetahs and gazelles, but in other organisms such as these bacteria and puppy dogs and polar bears and Darwin's finches, and pretty much everywhere that has been looked at, the evolution we see is devolution, losing things.
Right. Now, where you're at now at Lehigh University, you're in the Department of the Biological Sciences, and their web page basically had post a denunciation of you and your work as no basis in science. Even though you're working, they had make that known. Has this been your life story since you've come out with these conclusions?
Yeah. Well, yes, in varying levels of intensity. You have to realize that this biologists simply hate this idea of intelligent design.
Right.
You can criticize Darwin's theory, but you'd better have another mindless process that you're proposing to replace it. Otherwise, biologists are allergic to folks who propose things that might have religious implications. That, for example, life had to be purposely designed. Well, who's that designer?
Right.
And there's been a history between religion and biology ever since Darwin came out with his book. And so if you say something that smacks of teleology or intelligence in life, and you're a professional biologist, you're essentially signing your career death warrant.
Right.
Not only that, but in these days of the internet and so on, your colleagues will get harassed. And my poor colleagues at Lehigh, they have their own research. They just they didn't want to get involved. They didn't ask to be involved in this. And so I think they put that up more as self-defense.
Right.
Don't blame us. There's one crazy guy. And but if you look at the statement on the website, for listeners, the department put up this statement disassociating itself from me and kind of pledging allegiance to Darwin's theory. There are no answers to the questions that I posed in my books. Like I said, it's just a pledge of allegiance. So people are mad at it, especially colleagues and people in my profession, but they don't have answers. So until somebody tells me where I'm wrong, then I'm just going to keep plugging away.
Right. Well, a term I've constantly heard used in recent years is pseudoscience. And that's if you have anything reflective of intelligent design, it's immediately labeled pseudoscience. They can't explain why.
Yeah.
But it's like a code word for don't listen to this. It has a smidgen of God in it. Don't listen to it. It can't be true.
Well, pseudoscience is used as a dismissive term, as a polemical term, just labeling something as, I don't like this, does not answer any of the arguments of it. And if you look in the history of science, just a brief tour, you find a lot of things that were labeled pseudoscience that turned out not to be.
Right.
Beginning with Newton's theory of gravity, back in the day, people thought that to interact, two bodies had to hit each other, had to have a collision. And here was Newton proposing this spooky theory of gravity where two separated bodies like the moon and the earth affect each other.
Right.
And so other natural philosophers of the time, the scientists of the time said, that's pseudoscience. We don't believe in that. But turns out that he won the day. And another one was there was a theory of the ether. There was a theory that all of space was filled with something called ether.
Right.
And that was accepted by all the best physicists of the late 19th century. And now we don't believe in that. So scientists reject some things that were later accepted, and some accept some things that were later rejected. So unless you can actually give an argument against this idea, just calling something a bad name
Right.
does not do the trick.
I mean, I works on a playground. I don't know so much about scholarly scientific work.
Well,
Your
yeah,
idea is wrong. It's stupid.
yeah,
I mean,
that does work. Any adult social setting.
right. Now you have a new book that you're fixing to come out with called "A Mousetrap for Darwin." Now,
Yeah.
is this like a new addition to what you've been covering, or refining?
No, this is actually a collection of short essays and other things that were published in journals and
Mm.
on websites and kind of scattered around, and are hard for people who are interested in this topic to access. So
Okay.
Discovery Institute had the idea to collect all of these things into one volume, and so that's what this is about. And over the years, you might imagine, over the past 25 years, I've been in this area, and there have been a lot of criticisms published by some by philosophers, some by scientists, and I respond to all of them, and I show why I think their
Right.
arguments are incorrect. So it's the next level. It's not just the argument itself, but it's responding to criticisms that the
Okay.
argument has gotten.
When you project that's coming out, and when it comes out, where can we find that?
Well, it should be out in about a week.
Oh, wow, good.
Yeah, and it'll be available on Amazon, and
Okay.
so yeah, you can get a Kindle edition or hardcover or paperback, whatever. Yeah, so makes a great Christmas gift. Yeah.
It would make a good Christmas gift. Mike, I tell you what, it's been a real pleasure talking with you today about this subject, and I appreciate you being on the show.
Yeah, my pleasure. Thanks for having me.
You're listening to Rage of the Age. Rage of the Age. Politics, religion, economics, and history with a conservative bend.
Welcome to the essay segment. And I'd like to say again that it was an absolute honor and a privilege to speak with Michael Behe today. He's one of many people that I had come across in my search for trying to get at the bottom of things. And it was mind-blowing, the things I had discovered over the course of my later part of my life regarding the theory of evolution. Because the reality is I was originally a skeptic when it came to things like the biblical account of creation, for example. And I bought into the idea of evolution, hook, line, and sinker, survival of the fittest, things adapting over time, the common ideas that had been fed to me in my high school experience, and backed up through all of the media that feeds into the same idea. But something challenged that. And the thing that challenged that is what I'm going to simply call stubborn Christians. I could not fathom in my head how there were people who still wanted to believe in the biblical account of creation as it was written when we have so much, quote unquote, scientific proof to show to the contrary where everything came from. And it just kind of bothered me that they were unmovable by it. So I started on a course to basically put the nail in the coffin and go, there, it's been solved, let's move on, sort of thing, right? So what I did was I turned to the atheists to see, well, there's these bright minds like, Richard Dawkins and Richard Leakey and all these others that if I read what they have to say, they must have figured out they're so brilliant. I'll know what they know, and that will put this matter to rest for me. But what I discovered is it didn't put the matter to rest. It made it more agitated. What I saw in reading their works was they were just as uncertain about things as others are. They did not have definitive solutions on some things and admitted it as such, and would even criticize one another in what they were discussing regarding this idea of evolution. One thing was certain, though, in their minds: there could be no God, and that there was a process of evolution. Now, there was different ideas of how that came about, and this baffled me, because I'm thinking, now wait a minute, this is supposed to be scientifically done and completed, and this matter should be laid to rest. But when I was reading their things, I didn't see that. I didn't see the certainty I was looking for, and that bothered me. But then I ran into a group of, a genre, if you will, of writings that I never knew even existed before. And there's these groups of Christian apologetics or apologists that, they write about these things. I never heard of them. I never read them before. They're definitely not given the limelight in the scheme of things in society now. Often suppressed or called, ridiculous names so that, they poison the well so you don't even think about listening to what they have to say. I didn't even know they existed. So I began to read their stuff about evolution, and it kind of challenged me a bit. But what challenged me was some of those people were scientists, and that baffled me, because I had bought into the idea, like so many other people and many who do now, that for some reason science and someone's religious faith are incompatible. That if somehow you're a scientist, it's inevitable that you can't have any religious faith because your science is so informed. But I had come to learn that that's not really true. There are people who are in fields of sciences that baffle me as far as the material is concerned, and they're good at what they do. And they make their observations, and they make good conclusions. And that further drove me to even more questions. How can these people in these scientific fields have a faith in God? Eventually, it unleashed in me what I was, a skeptic. And what I began to do was to become skeptical of everything I had been told up to that point regarding evolution, to where I was like, okay, now this is shaky ground. You're going to have to do a lot better to prove to me, other than what you threw at me in high school, what you throw at me in the media around us, and this person's book and that person's book. You're going to have to give me something far more substantial, because I'm going to criticize it. I'm going to be skeptical. And by that, I don't mean I'm just being mean-spirited. I mean, you have to prove it to me. You claim to be the people of proof. Show me your proof. And of course, the answer is always, well, evolution. The basic premise of evolution is this, though, that the simple becomes more complex over time, which then creates more complex things. And then you have more, complex creatures. That you start with the most basic of life, and that evolves, meaning it improves. It gets better until you have better things. And that there's always this process through time. And this has to happen over countless years, an eternity, really, for this idea to really take place. And they're comfortable with the idea of there being as much time as you need to make it happen, right? And it's based upon this idea that things change. And that's the trick of it. That's really what gives it some validity if you only look at the surface of it. There is changes. There are things that are altered through time, through species. We observe this, and like I've mentioned in the interview, humanity has seen this over the centuries, over the millennia. It wasn't a new thing for us to understand that. It's just when you take that premise that, look, these things have changed over time, that must be the mechanism through which life originated. That's a huge jump. That is a very huge jump. But there's something needed for that to be the case. Life. We see that life changes, but we never see life just suddenly burst from nothing. Does life seriously, spontaneously spring from non-life? You have no matter, and suddenly matter appears. I'm pretty sure we don't believe that. I mean, Louis Pasteur kind of demonstrated that in experimentation that that's not the case, right? But why are we holding that out as a possibility then? If it's not to simply make the theory fit. You have to have life to begin with before you have these changes to say, see, that's the mechanism, but you don't tell me the origin of where that life came from in the first place. Really, it goes like this. No matter where you give me a starting point, I can always ask you the question, where did that come from? Because we know it can't just pre-exist for an eternity. Why? We live in a setting of decay and atrophy. Things don't live eternally. Life does not live eternally. So where did that come from? Well, it came from this. I can always ask you, where did that come from? Eventually, you're going to get back to point zero where there's nothing and something appeared. Now, we know, naturally speaking, that can't happen. But that's where we go to. But you know where it can't happen? When the supernatural intervenes and makes it happen. But if you don't want to go back that far, I mean, because there's so many arguments that's had on that too, and I don't think anybody's listening in it. But look at the facts. At the most basic of levels of life, at the molecular level, we see irreducible complexity. And this is one of the things that when I had seen years ago that Behe had presented, and I was watching, like I said, this video of it and these things moving around, and I'm seeing actual machines, biological machines, at this very beginning level with an irreducible complexity. I mean, the idea before was that somehow protein formed on its own and built into bigger life. But look at the protein. It's like they're a built-in machine. How did that suddenly just appear? How do parts just exist and suddenly find meaning together and form some kind of entity? That's like saying about the human body that, lungs lived over here doing their own thing. Hearts lived over here doing their own thing, right? The digestive system was its own little entity over here. The eyeballs were kind of over here doing their thing, but at some point they picked each other up along the way and they formed this complex mechanism. That's kind of what we're saying. We're irreducible too. You can't just start ripping stuff out of us and we live. You can't rip out my lung and leave it by itself and it's going to live. It's the same with the proteins in a cell. They're irreducibly complex. You can't go any lower, yet look at the design in it. And that's the frustration that I think many of those who don't want to accept that there's a God runs into. There is no building upon the simple here. You start with the complex. And as was mentioned in the interview, if there are any beneficial mutations, it's simply because what already exists is broken down. It doesn't improve, it breaks down in its adaptation. This is not a basis upon which you can build an idea that evolution is a viable explanation for the origins of life and accounting for things as they exist now. It just doesn't. It explains things that change and alter and are affected by conditions perhaps, or a breakdown of certain genetics, but it does not go beyond that. And I want to end this essay by simply stating that there is a God. There's a God who created all things. His signature is throughout all of creation. And that is why the Bible says that mankind is without excuse, because the mighty presence of God is evident in everything around us. We are without excuse. We cannot say there is no God, because everywhere we look, we see his evidence. We see his signature, and it's in everything. And you can't just arbitrarily wave your hand and say, well, that's not the case. It must have came from, well, nothing.
You've been listening to Rage of the Age. If you loved today's podcast, make sure to leave a review on the media you're listening through. Secure future episodes by heading over to rageoftheage.com and clicking the RSS feed button. Until next time, this has been Rage of the Age.